Alright, for this video you're going to need the document that is labeled Parent Functions. This is a prerequisite to Unit 1.5, which is about transformations. If you do not have the worksheet labeled Parent Functions out, hit pause, find that, and then hit start. So, as you're looking at this, you see that there are 8 different functions that we are going to talk about today. Linear functions, absolute value, quadratic, square root, cubic, reciprocal, logarithmic, and exponential. We're going to talk about what is different about each of these and what is the same about each of these. So we are going to be looking at the most basic form of each one of these. That is called the parent function. So what we are really trying to take from this is what is the basic shape of the function? What does it look like? What do all linear functions have in common? So we look at this, and linear comes from the word line. So a linear function is really nothing more than a line. The basic linear function, f of x equals x, means whatever you plug in, that's what you get out. Negative 2 comes negative 2, negative 1, negative 1, 0, 0, 1, 1, 2, 2. Whatever you put in, that's what you get out. That is your most basic linear function. Now, there are 2 points on each one of these functions that we are going to pay special attention to. It is the 0, 0 point and the 1, 1 point. We are going to find that each one of these functions has the 0, 0 point and the 1, 1 point as a point on the function. That's going to be true of our first 5 functions that we look at. The reciprocal function does not have the 0, 0 point because 0 is not an element of the domain. However, it's still centered around 0, 0. And then the logarithmic and exponential functions, they're a little bit different, and though we are going to touch on them just so that we can recognize the shapes, we will not be analyzing the logarithmic and exponential functions until later in the course. So first, like I said, here is our linear function. Whatever we put in, that's what we get out. The basic linear function, f of x equals x, and it does contain the point 0, 0 and the point 1, 1. The next function that we will look at is the absolute value function. Now, the main thing that we're taking from looking at these parent functions is noticing the general shape of the function and some of the important points. So all absolute value functions have this V shape. Over the next couple of classes, we are going to take that and we're going to move it, flip it, stretch it, compress it. We're going to do all kinds of things to these functions that make them look a little different than the way they look now. But they will always maintain a basic relationship with the parent function. So the parent function of the absolute value is just this absolute value of x. It's represented by an x with 2 parallel lines surrounding it. When we take the absolute value of something, we are looking at its distance away from 0. Distance cannot be negative. So computationally, what that means is whatever you have inside the absolute value becomes positive. If it's negative, it becomes positive. If it's already positive, it just stays positive. Again, on each one of these, notice 0, 0 is a point on this function, and so is the point 1, 1. We saw that in the linear function. Notice when we plug into this absolute value function, we have that 0, 0 point and that 1, 1 point again. We have what is called a quadratic function, and a quadratic function is one that has a square in it. So as you can see, the parent function for the quadratic is f of x equals x squared. Make sure that when you square things, you are paying attention to order of operations. If f of x equals x squared, that means that if I take f of negative 2, that will be negative 2 squared. I put the negative 2 inside the parentheses when I do that. That way negative 2 times negative 2 gives us positive 4. Negative 1 times negative 1 is 1, 0, 0, 1, 1, 2, 4. The quadratic function looks like a cup. It's got that cup feature. If you flip it over, it looks like a mound. But it always, like I said, we're going to move it, we're going to flip it, we're going to rotate it, we're going to do some things to this quadratic, but it will always maintain that same basic shape. What we are primarily trying to get from this, making sure that by the time we really start working on 1.5, we need to know these basic shapes as being the different types of functions that they are. As with every other example I've given you, I'm going to just square off this 0, 0 and that 1, 1 point. I think you're starting to notice these other points, they vary from function to function, from shape to shape, but that 0, 0 point and that 1, 1 point, they have been present in each one of the parent functions that we have looked at thus far. Our next function that we are going to look at is this square root function. Notice that in this case, I picked some different x values. Now, for the first 3 examples, I did use the same x values just to give you some sense of continuity, to give you some sense of how different things are relating to each other. But you get to pick the x values. That is why we call x the independent variable. You get to pick x. Now, we talked last class period about radicals and domain issues. So since that x is inside of that square root, we know we cannot insert negative numbers. So putting negative numbers in doesn't work. If we're going to take the square root of a number, it makes more sense to use perfect squares. That way we get easy numbers out for our f of x value. If you put in 2, well, you're going to get out the square root of 2. And we all know that the square root of 2 is 1.41 something, 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 something. But we don't all know that the square root of 2 is 1.4 something, 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 something. So what you need to do is pick x values that are easy to work with. So the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, and we end up with this kind of curved shape. So just to notice, and we're not doing anything with this yet, but I do point it out every time. We have that 0, 0 point, and we have that 1, 1 point. And the reason I'm pointing that out, again, is because when we start moving this thing around and stretching it, utilizing the fact that the base function had 0, 0, and 1, 1 will allow us to work with the more complicated functions later in ways that you'll see in the coming lectures. Our cubic function takes things to the third power. It's got this kind of S-y shape to it, not really an S, but it's got kind of a squiggle line. Flattens out a little bit at the 0. Negative 2 times negative 2 times negative 2 is negative 8. Negative 1 squared is negative 1. 0, 0, 1, 1, and 2, 8. And again, you could go on and put 327 and 464, and the domain and range of these have all been, we'll talk about the domains and the ranges, but the domain of this is all real numbers. So you can plug in bigger or smaller numbers, but just around the origin, that's the basic shape that we're getting. Now, next we have the reciprocal function. Again, all I want is for you to see that basic shape. It's got that swoop down and then that other swoop up in the up. We are not going to work as much with the reciprocal function yet. This is an example of a basic rational function. We're going to do an entire unit on rational functions later on in the class. But what we do want to notice about this reciprocal function now is just what it looks like. We plug in negative 4, we get negative 1/4. We plug in negative 2, we get negative 1/2. We plug in negative 1, we get negative 1. We plug in negative 1/2, we get negative 2. Now notice, as we are getting closer to 0, our values are getting more and more negative. We get to 0, and it does not exist, right? Because we cannot plug in 0 into 1 over x. 1/2 becomes 2. We still have the 1, 1 point. 2 is 1/2. 4 is 1/4. So as we come to 0, we get larger and larger, but we cannot actually touch 0. And then as we get away from 0, we get closer and closer to that x-axis without actually touching it. We're going to use some fancy words later called asymptotes, and we're going to talk about points of discontinuity and all kinds of stuff when we get to this later. But for right now, what we notice, at 0 it does not exist. It does still have the 1, 1 point, and it's still generally centered around that 0 point, even though the 0, 0 point is not there. So that's really all you need to know about reciprocals. Be able to recognize the shape. With logarithmic and exponential functions, we're not even going to worry about what you're plugging in. We're not going to worry about points that they have in common or anything. The logarithmic function, notice that it gets very close to the y-axis without touching, comes up and kind of shoots off. Exponential is asymptotic, or becomes very close to the x and then shoots up. Really, knowing what the shape is all that's really necessary. We are going to do an entire unit on logarithmic and exponential functions. So at some point you will understand these perfectly, but for right now, you just need to be able to recognize the shape of a logarithmic and exponential function. So make sure you understand your shapes. Make sure you know what's going on with what we've talked about in this little video. This will definitely help you. The better you know your different types of functions, the easier transformations will be for you. So until next time, this is Mr. Smith, and have a fantastic afternoon.